Can I get some help, please? I'm not sure I'm opening the right folder. Yes, I'm trying to find my talk.
I just think that you are alone here. I don't know why. Okay, so up.
Yeah, I think so.
Where did you put
Where-
the...
it- maybe it's in all of that.
it's also in here. Okay.
I'm sorry. My AM2.
M2.
Yes,
Okay.
thank you. Thank you. I'm a math person, what can I say? Okay. All right. All right. Well, since we have the same audience and it's in the same room, I might be able to skip some parts of my talk. This is more the social side and the citizen science side of my program. It's called the Paca Project, standing for Pro-Am Collaborative Astronomy. And essentially, it came about by all these campaigns we have. One is a NASA-driven Comet Integration Observing Campaign based on the way the modus operandi of how we did Comet ISON last year. And then also, I'm the ESA Rosetta Coordinator for Amateur Astronomy Observation 67P, which is a long-term project because it's not going to get really bright and also towards the northern hemisphere until next year. And so I also admin all the related Facebook groups and the social media for all these groups. Okay, based on ISON lessons, what I found is that basically there are 4 aspects of any kind of pro-am collaboration. And the first and the most important is driven by the science. What is the gaps in our knowledge of science? And that defines what is the observation that we need to do to get to that science. And thereby, we start integrating scientists, the community image, and then with the help of technology, you can do animations, look at the old legacy data. And so this is where we can build a community of researchers consisting of scientists, data scientists, observers, as well as students. And then as we basically adopt and adapt to the social media world nowadays, so we try to expand to all these different social media, and the outreach part is not only the science results that are being presented, but also the the citizen science that we do. And here I am going to extend Pamela Gay's definition of citizen science a little further. She talked about public, wanting to learn new science, and that's what I find with the amateur astronomers. They're also the public to me, but they're also my peers, and they also are helping us get new data, and they're all volunteers. So in that sense, there's citizen science going on here too. And so here's one of the first magazines where it actually, this is the main story, that this is the new social face of astronomy. So this is where I got the idea that, hey, you know what, we need to be doing this because the amateur astronomers tend to share and exchange information very quickly and virally through different aspects of internet. And so this was where they picked up on our Comet ISON Facebook group as the first outreach project on this. And since then, there are many groups that have come about. So what's the need for social media? There's so many. You can pick one dimension. You can pick multiple choices. The choice is yours, what you feel comfortable with. Facebook has immediate global visibility. Pinterest is almost like a pinning board, so you can show your latest images there. We have Twitter if you want to follow or share immediate stories. We are building a website so that all of these are going to be fed into that. We have blogs written by different people. Flickr for albums of not only the project, but also for the amateurs who want to have photo albums as a collection where they can put their work. And then we're testing Google Hangouts. In fact, we're having our first one today, right after this session, for Siding Spring to talk about how to improve. Once you take your data, what do you do with it? So that's a pilot program. Hopefully, it'll be successful. And so what we do is, it's not just us saying, hey, we want data on this topic, go get it, and we'll analyze it. What we try to do is we have all these things going on, and there are different levels of advancement as well as development, depending on the experience of the amateurs, the science that needs to be done. And so one of the first things you do looking at comets is we want to get a timeline or morphology of how the comet evolves. And so you need light curves. And then we have not only individuals, particles, but we also have robotic telescope networks, like I'll come to that later. And then we start sharing the results through the group first, and then through meetings, and then eventually papers. So that's the science outreach, and all of this is going on. And then, so this is ongoing. These are already established pipelines and methods that we're using and sharing with other scientists as well as amateur astronomers. The items in blue are ongoing because we have so many comets, and it's not just Siding Spring 67P and ISON, but there's so many other comets in the sky. And so our amateur astronomers, basically on a given night, they look at all the comets available. And so all of these things are happening right now. The ones in the green are basically what we are planning to do, because that's the aspect that isn't well-defined. Spectroscopy is just starting. Polarimetry is very difficult to do, but it's very essential. Lab measurements are another area that is lacking. And the archival of this data, where do we put it? Everybody has so much data. I personally cannot store it. And so we're trying to find a way to have a temporary storage area so that once the data is scientifically validated, it can be deposited into the NASA Planetary Data Science System, as well as or the ESA Planetary Science Archival. And that's where people will go to get this data to do further analysis. And this method, inviting and including amateur astronomers from around the world, was for well illustrated in this paper on a comet 103P Hartley, the Meach et al. Which she basically had a group that included, this paper included 125 authors that included all the professionals as all the amateurs that were observing Comet Hartley with all sorts of telescopes all around the world. And between the two communities, they were able to get the full spectral energy density of the comet. And that's important because the reflected part of the comet SED curve tells you about the optical properties of scattering by the comet particles. And then the longer wavelength, the thermal emission, gives you some information about the brightness temperature, and the two together then put constraints on the kind of models that you can use. So this is not only multispectral, but it's also the bridge between professional and amateur observers. And so the robotic telescope networks that are partners with us right now are Virtual Telescope. We heard Jean-Luc Amasi talk about that. Nick is at the FOC Telescope. And then we have a new partner, itelescope.net. It has telescopes in New Mexico, USA, as well as in Spain and in Siding Spring. And so between the three, we try to get as much information as we can, and it helps provide a continuous timeline of data from different observers, as well as on different objects. And so if the weather is bad in one location, then you have, it's an insurance, you can get good data from another location. Now, this I proudly show because when we did Comet ISON campaign, we had a logo contest, and so all our members put in the entries, and we decided this was the one that we really liked. It indicated the campaign, it indicated the comet, and also basically here's the amateurs and the professionals, and there's the comet. So it kind of integrated all our themes. And here's a sample of all the gallery of all the images we've had, which shows from discovery and characterization of the comet as it grew. And then here we also have modelers who basically take the data and then create the light curves as well as magnitude versus time, or AFRO, which is a numerical method of basically identifying how much dust activity is going on. It's a proxy for that. And so if it's high or it's varying, then there's dust activity produced. But if it's flat, it means it's very quiet and there's a very quiet comet. And so after the discovery, here's the evolution before it disintegrated, as you see from different people. Names are all on the pictures. But this is the famous montage that Damien Peach created, when the comet essentially, after this last observation, basically disintegrated. And so so these are the kind of, this is the quality of the pictures, there's the quality of, quantity of data we have in terms of coverage, time, and location. And then here we have one of the first spectra of comet ISON was gathered by one of our amateur astronomers, Rob Kaufman, who basically had done similar work on other comets and found that this was neither too gassy nor too dusty a comet. And this was used, this was essentially just came out ahead of the professional optical spectrum, so, and this it matched rather well. Okay, so I kind of mentioned that. And this one, I'm very proud of this one because here we had an amateur astronomer in Spain, Granada, Spain, who was observing this, and a few hours later I was observing at a professional telescope, and so there was an outburst. That's the start of the end of comet ISON's disintegration. And so the night before we had measured the thermal brightness of the temperature, and the next day we'd measured the outburst temperature, and so you can see it went up by 40 degrees. And this is the only thermal emission spectrum we have in the world because after that the comet didn't exist. So we basically do all these things, and so from out of that grew Paca, and so what we do is it's really a forum for different types of campaigns. We basically we're doing NASA-directed campaigns. I'm also working with the ESA Rosetta Project, but we also have independent campaigns, comets that are very interesting that have been discovered, like Q2, the Lovejoy comet. He's a member of our group, and as soon as he put it on a possible confirmation page, the other members immediately went and got a confirmation that observations, so that immediately got a designation. So now for all these independent, these other comets, we have similarly all the social pages made for them, including the website, the Facebook page, Twitter, etc. So within a couple of days of having a designation, we can actually add that to our project. And so it starts off with registering so that we know the information about the amateur astronomers, what they're going to provide, and also we know what the capability is, as well as what they're bringing to the table in terms of their location. And so this helps a lot because a lot of our amateur astronomers, they learn from each other, and so it helps to know what level of expertise it is. And also as a professional, I learned quite a bit myself, so it's always nice to know that information. And then we have shared documents on Google, so these are documents that are centrally located so that people can share them, and they're kept separate from the Facebook page because Facebook is really not meant for a truly collaborative portal, and so we do all this separately, but people from the Facebook can actually access these. And similarly, we have shareable files so that people can put their information and then we can share that so we can edit for like papers or putting data here. And this is a location that's possible for putting in the science data that's in the FITS format as opposed to images on the other social media. And so now the two projects we're doing are Sighting Spring. Again, the same person designed the logo for us. Sighting Spring is going to go by Mars on October 19th, and it's very exciting. It's going to be mostly observable from southern hemisphere, primarily South Africa, where the comet will be circumpolar at that time. And we also have great planetary imagers. This is Christophe Pellier, but we also have Wesley, as well as Paul Mason and Efren Morales. And so we get both the planet characterization as well as the comet. And because this has been going on for months, we are actually characterizing the seasons on Mars because in April, when we started observing this, it was basically perigee, and the season changed from spring to summer, where the cloud structure changed. And then from August 17, the seasons changed again. Now it's going into fall, which is dust storm season. So it's a month ahead of the encounter. And so we have to see what the atmosphere of Mars is going to look like. But this is the kind of quality of data we get. And we are working with JPL, trying to see if they can do any kind of three-dimensional reliefs of this, as well as creating three-dimensional files that one can print. And the Rosetta Mission, as Matt Taylor, the project scientist, calls it the sexy mission. Basically, everybody knows what it does. It has a lander built on top of the spacecraft. It's going to deploy the lander, which will land on the comet on November 11th. And then the orbiter is going to go into an orbit around it. And after that, it's going to escort the comet to its perihelion date in August 2015. And this is just a diagram of its orbit. And so how are we supporting Rosetta since there's since the orbiter takes such beautiful pictures? Well, we have a ground-based, two-pronged ground-based campaign. One is the professionals that Colin Snodgrass is overseeing, and I'm doing the pro-am through all the different social media, but also we are taking data. And so I'm not going to go too far beyond this, but the point is, why do you want to look at a comet when this is the kind of pictures you're getting from the spacecraft? Well, you're getting these kind of pictures, but you're so close to the comet that you cannot see the far environment. This is a picture taken from the VLT telescope in Chile just a few days before this in August. And basically, you can see that there's a coma, and so we can't really resolve the nucleus inside. The lander as well as the orbiter will do that. So and this is from one of the telescopic robotic telescope networks, eye telescope taken from Australia in Siding Spring by Peter Lake in 4 different filters. So this is from the large telescope, and you can get, but you'll get very limited amount of time awarded to you. And here you have access to the telescope, and you can use it whenever the comet is available. And here you get the high resolution pictures that you normally cannot see. So each of them gives a different perspective, and each one of them is important. And so here are all the social media pages for 67P. But this is where I think is more important for all the amateurs to take a step back and see. It's very good that all of you take so many great images, but the point after that is, what do you do with the images? So if you want to make them scientifically valuable, then there are certain things that scientists need, as in, first of all, we need to know the formats. We need to have proper logs as well as an absolute calibration if possible. The format of the file is something that we like to have consistent for amongst all the observers. And then we need to have some rules of the road. How do you access this? Because the benefit of social media is that you can immediately go viral and share it with everybody. But sometimes when you're working with teams, then you have to have a sense of proprietary and ownership of the data. And so we need to have access for both the professionals as well as the amateurs. And so these are things that we need to do, because if you want to publish in a scientific journal, if the data has already been shown somewhere, some journals don't accept it. So you lose that opportunity to showcase your own data. And then, of course, how to put it on an archive, and a planetary archive that other scientists can use. So I think those are the biggest challenges that I'm working on right now. And also we have our independent campaigns of other comets, Oikomaiden, Lovejoy, that was discovered just a few weeks ago, and Jacques, that's beautifully placed for the northern latitudes. So there are other, as we see more comets and that become bright and no other mission is going to be addressing it, we then quickly add it to our project, so it's going to expand in that sense. So I welcome anybody who wants to join this to contact me, and please let me know if you have data on any of these comets. You're welcome to join our database as well as our groups. Thank you. I guess I went over time, so if you want, you can ask me a question. Otherwise, you can ask me afterwards. Yes.
If we could use those amateur images of, like, let's say Rosetta Mission, if there is a huge quantity to determine position of spacecraft, is there any chance, you think?
Yes, actually, that's one of the goals of the ground-based observations is whenever we can get data, we want to be able to collaborate with the scientists and crowdsource it. So there, everybody has different ways of doing it. So there's no one technique right now, and there aren't all that many techniques I know of data mining, but different people may have ideas, and so we can crowdsource it among scientists and amateurs. And yes, we are having plans to do that, but we just don't have a lot of ground-based data yet. The object is not only faint, but for a lot of northern hemisphere people, it's not available. But starting next year, and this comet is interesting, 67P, it gets bright a month before perihelion and then gets brighter 3 months afterwards. So next year, from about March, April, through November would be a good time for the amateurs to really be getting involved. So this is a good time to practice on all the other comets so you know what to do when it's available. All right, then I guess if there are no other questions, then we will close the session, and thank you all for staying till the end.